Hi everyone, we are on our last Excel lab. I know I've probably driven you all crazy with this, but I hope you've at least learned a few skills while doing all of these labs. So in this last lab, we are going to analyze some data from a questionnaire and some data from a few weekly activities and see if there are any correlations. So I went ahead and started to fill out the spreadsheet. I just put some random numbers for the exercise variables, for the questionnaire scores, and then I put this table over here with all of the categories that we are analyzing. So we're going to do two types of correlations. We're going to do a Pearson correlation and a Spearman correlation. And what we want to do, since you can only analyze two variables at a time with this method, we're going to make a dynamic spreadsheet where we can select which variable we want to analyze in this column, and it will automatically fill out. So you don't have to keep doing correlations multiple times in a row. You can just change the column and it will automatically adjust. So that's what we're going to do. So let's get started. So now, in order to make this spreadsheet dynamic, we're going to use the data validation tool to basically allow us to create a drop-down list, and then we'll select from our categories and it will auto-populate based on our selection. So throughout this lab, we need this data written in two different ways. So because we're going to use the VLOOKUP function to do this, VLOOKUP has a specific way it reads. It reads column by column. So we're going to create another table with this data and swap the columns and rows. So I'm going to press copy and then go to the cell that I want to paste in. I'll go to paste special and then go all the way down to paste special and transpose. Make sure that's checked, press OK. And you can see that it swaps the column and the row. So this will be easier to work with for our VLOOKUP functions. So in cell D3, we're going to go to data and we want to use data validation. So we'll click this data validation button and we're going to go to list, and our source is going to be which choices do we want to choose from. So we're going to use these categories here to do that. And you can see now we have a drop-down list and we can adjust as needed. So now we need to auto-populate the values that we have. So we're going to use the VLOOKUP function for that. There are probably other functions you can use, but the VLOOKUP function is relatively simple, so I'm just going to use that. We'll do cell D3, and this is our table that we want to reference. We do want these in dollar signs here. Now for each row, we're going to have to tell the VLOOKUP function which column to reference, and we'll have to do this for each column basically. So we are going to start with the second column and make this an exact match. And you can see that for the work school category, the first number that we should have is 8. That matches. So I'm going to copy this and just adjust the column one by one. So for the next one, we'll adjust to column 3. And we will adjust to column 4. And so on until everything is filled out. So now this column should match this row here. So if we go and change this, you see that it automatically changes and adjusts the data based on which category we have selected. Okay, now we can see if a correlation exists between two variables. So if you haven't looked through the lecture information on Pearson correlations and Spearman correlations, I would recommend doing that. But just to briefly sum up, you can use a Pearson correlation if the two variables you are comparing are ratio variables. So it's basically numerical data. This is ideal to be able to just compare numerical data with numerical data. Will give you the most accurate results. You can still use ordinal variables and ranked scales and get valuable data that is relatively accurate. But researchers do tend to strive for collecting at least some numerical variables if you can quantify something. So we can use a Pearson correlation if both variables are numerical ratio variables. If you have variables that are scaled scores, or one is numerical and another is a scaled score, you need to use the Spearman correlation for that. So in this case, since we have exercise calculated in hours and we have these variables calculated in hours, we can use the Pearson correlation for that. We cannot use it for the questionnaire scores because this is a scaled score. So let's just start off and calculate these coefficients. So there's multiple ways of doing this. You can go to data and go to data analysis and select correlation, but it's not going to give you the p-value and it's not going to give you all of the information. So we're just going to calculate the p-value, and it's not really that difficult to do. It's just a mathematical equation basically, so we can easily calculate it. So to start, we're going to go to cell C14, type in Pearson, and then we basically just select the two variables that we are comparing. So we will select variable 1, and whichever variable you choose from the drop-down list. It doesn't matter because you can adjust it at any time. We'll compare those two variables and you will get a coefficient. So again, look through the lecture slides to know how to interpret this, but basically this is a negative correlation, and the closer to 1 or -1 a number is, the stronger a correlation. The closer to 0 it is, then a correlation doesn't exist or it's a very weak correlation. And positive or negative indicates the direction that the variables are influencing each other in. So an increase in one variable causes the other variable to increase. That's a positive correlation. If an increase in one variable causes the other variable to decrease, that's a negative correlation. So now we can determine if this correlation is statistically significant. So to do that, we're going to fill out a few values and then calculate the p-value. So now that we have our Pearson coefficient calculated, we need to determine n, which is just the number of pairs. So it is important that your variables have the same number of data points that you're analyzing. If one variable has more data than the other variable, you need to make it even. So n is basically just going to be a count function, and we're just going to count the number of data points that we're analyzing. The next cell is the test statistic. So basically a random variable is calculated from the sample data and used in a hypothesis test. And it compares your data with what is expected under the null hypothesis. To do this, we need the Pearson correlation coefficient, and we need the number of pairs, which is n. So this is the formula that we're using. So the ABS function is going to take the absolute. So if you notice, this correlation is negative. So that's going to create an error in calculating our p-value. So we just want the absolute value, whether it's positive or negative. We just want the 0.35872 value. So we're going to take the absolute of the Pearson coefficient times the square root of n minus 2, all of that over the square root of 1 minus, again, the absolute of the Pearson coefficient squared. So df stands for degrees of freedom, and degrees of freedom define the shape of the distribution that your t statistic is using to calculate the p-value. So, for example, say you have 7 shirts and want to wear a different shirt each day of the week. On the first day, you have the most options. You can choose any of the 7 shirts to wear. On day 2, you have 6 options to choose from. On day 7, you have no choice but to wear the remaining shirt. So 7 minus 1 equals 6. So that means you have 6 degrees of freedom in which your choice can vary. So the df value is analyzing the data that is free to vary in your sample. And p-values are linked to degrees of freedom. So the higher the df value, the higher the likelihood is that your results are statistically significant. So to calculate this, we are going to basically take n minus 2. And now we can calculate our p-value. So we're going to use t-dist, and we'll take our test statistic, our degrees of freedom, and if you remember a while back when we did t-tests, you can choose a one-tailed distribution or a two-tailed distribution. Most tests are going to be two-tailed, where you're analyzing both sides of the bell curve, both extremes basically. And then we are going to press enter, and now we have our p-value calculated. So this is not a statistically significant result, as you can see. Now you can change this around and see how your data changes. And we can see that this has a very strong correlation, and it is a statistically significant result. So you can play around with it and see what you get.